All right, great. All right, so this is continuous integration for Perl with Azure Pipelines. My name is Dave Rolsky, and let's get started. So first question was continuous integration. Well, some of you were probably at Mark and Olaf's talk yesterday, and Olaf did answer this. And even if you weren't, you probably know this already, but I'll define it anyway. And the simple version is just running your tests on every commit or push. You can do a lot more with continuous integration. You can build Docker images. You can do all sorts of stuff, and you can take it to continuous deployment as well. But really, this is just going to focus on tests, at least for the first half of this talk. And actually, I should say this is really there's two chunks. There's a chunk about my project for testing on Azure, testing Perl projects on Azure, and then a chunk where I just talk about some of the Azure features. And with continuous integration, besides running the tests on every commit or push, you also want to block your merge and deploy actions when tests fail. And that's really easy with things like GitHub or I assume GitLab, where you can hook it up to your continuous integration system. And if you have a PR that is failing its tests, it won't even show the merge button, or at least that's an option you can enable. So Azure Pipelines is part of the overall Azure service. Azure is Microsoft's cloud services offering, like AWS or Google Cloud Platform. Pipelines is like one part of this huge set of services. Much like AWS, there is an infinite number of services that are available, but we're just going to talk about pipelines, and it's a CI tool that's part of that. So why did I pick Azure? There's a few reasons. One, it's totally free. Two, it supports the big three platforms, which are Linux, macOS, and Windows. When I was starting on this project, there's a million CI systems. There's just so many. But there aren't that many that are free with no usage limits and that give you access to all three platforms. With Azure Pipelines for free software stuff, you can run 10 jobs in parallel, which is great. It has a whole lot of powerful features, which I will talk about some of them, caching, job templates, all sorts of stuff. And maybe most importantly, when I picked this, GitHub Actions didn't do all this stuff. It didn't even have caching. And this was like a year ago, maybe. So it's possible I'll switch this to GitHub Actions in the future, or just offer support for both. I'll talk a little bit more about that later. So let's talk about this project. It's called ci-perl-helpers. It's just a repo on GitHub. Here's the repo link. And basically, it's a set of templates and tools for testing Perl projects in Azure Pipelines. And it was inspired by a project that Graham Knopp created, which is travis-perl/helpers. And I used that for many, many, many years. I mean, I still have stuff that I haven't switched over. And it was just a set of tools for making it easier to test Perl projects on Travis. And specifically, it made it easy to test with many Perl versions, which is something that can be a bit of a pain on these systems, because you boot up a VM or whatever on the system. Yeah, it has a Perl, but it doesn't have dozens of Perls. So making this easier is really nice, and this project was great. By the way, I forgot to say at the beginning, if you have questions, I am reading chat. Feel free to put them in there. Feel free to raise your hand, and Dawn can unmute you, or you can unmute yourself, really. So yeah, all right. So the quick start for this project, you have to do this thing called creating a service connection. And I put some docs in the README. It's a little annoying that you have to do this. Basically, to access another repo in Azure, not the one you're testing, but something else, you have to do this setup step. This is something that GitHub does not make you do, which is nice. And then you make a YAML file. Everything's YAML. I don't really love YAML, I'll be honest, but all the CI services use YAML. So this is the opening stanza. You have to kind of declare that you're using this other repository. And specifically, you have this name and this endpoint. They can be different. The name is the name of the repo, in this case on GitHub. The endpoint is the service connection name. You can have them be the same, or this endpoint could just be called GitHub, because really you're just connecting to GitHub with this service connection. But I, in the docs, just keep them the same for simplicity. And then you have this other bit where you reference these templates in my project. So you can see it says template : the template path, and then @ ci-perl-helpers. So that's the repo here. And then you can reference it by name here. So we have the build template. We have a Linux template with some parameters, and I'll get into more of what this does in a second. And then there's macOS and Windows template. Any questions so far? All makes total sense. All right, cool. So when you do this quick setup, you get kind of my defaults. And by default, what you get is on Linux, we're going to test every Perl with the latest patch release from 5.8x to present. So 5.8.9 and so on up to 5.30.3. I don't know if 5.32.0 is available yet. It's supposed to be doing it via cron, but it's really hard to test that because there's not new Perls often enough that it's easy to test. So it might not have made 5.32 available. It also tests with the latest dev release, which when I wrote the slides was 5.31.11, and bleed, which is the most recent commit in the Perl Git. And when it does this, if you have a test failure with dev or bleed, the run won't fail, that's fine. But if you have a compilation failure, it still fails the entire run, which is a little annoying. There's not a way to mark a particular piece of this as allowing failures the way you can in Travis, and that's a feature I miss. And by default, all the tests are just run with unthreaded Perls. There's no threading involved. On macOS, we just get the latest stable release from PerlBrew. On Windows, we use Berry Brew and get the latest stable release there. So it's whatever is available. But you can also pick the Perls you want. And there's a lot of flexibility here. So you can set from Perl and to Perl. You can see an example here with from Perl. I just said 5.10. That'll get you the last patch release of 5.10. But you can also pick a patch release of Perl. So in to Perl, you see 5.30.0. You can include threaded Perls in your builds, which says, OK, I want you to use all these Perls, and I want you to build threaded and unthreaded versions. There's no threaded only option. If somebody really wanted that, it wouldn't be hard to add. You can also, for to Perl, really, it's most useful. You can say latest, just the string latest, get the most recent stable release. And you can pick from any Perl available via PerlBrew on Linux and macOS, or Berry Brew on Windows. So there's a lot of flexibility. And as you can see, you can also just pick arbitrary sets of Perls. That's the second example. And just one more note about include threads. If you're testing anything that has XS code, you really want to test with both threaded and unthreaded Perls, because it is possible to have XS code that doesn't work properly with the threaded Perl. It's depending on what's in your XS, it may or may not be likely, but it's a good idea. It also supports coverage testing, so you can pick a coverage service if you want. You can also just generate an HTML report. By default, this is going to use the most recent Perl version. And by the way, I think coverage works. I'm not sure if I've tested anywhere but Linux. I think it would work elsewhere. And you can pick which coverage Perl, or which version of Perl you want for coverage. It supports like coveralls, CodeCov, Critica, and a few other things. You can also just generate an HTML report the way Devel Cover does, kind of what's built into Devel Cover, and you can make that available after the run for you to view from the CI system. And it also supports partitioning the coverage testing into multiple partitions. If you've done testing with Devel Cover, you will know that it slows down your test suite quite a bit. So if you have a very large test suite, like with Moose, you really don't want to run it all in one job. That job will be very slow. So you can say, oh, partition this into 4 partitions, and it just does the right thing. Right now, there's no support for doing that with non-coverage runs, but again, that wouldn't be hard to add. Dave Jacoby, your question, yes, to Perl latest is allowed. I mean, even from Perl latest will work. And also, one thing I didn't mention about to Perl and from Perl is you can just have one of those. So you can say to Perl latest, which is equivalent to the default, or you could do from Perl 5.12, and then it'll just pick all the latest patch releases from 5.12x onwards. I will get into what the testing does, Andy.
Good question.
What am I using it for? I'm using it for testing cPan, my projects that I upload to cPan. And William, yes, coveralls is coveralls.io. Good questions. All right, so there's a whole bunch of other features. The system figures out your prereqs based on the metadata from your distro, but you can have extra ones that will be installed, particularly if there's something where it's like not mentioned in your code, but you check for it and then your code does something different, you can just install this. You can also install various system packages. So in Linux, we're using apt. Any apt package is viable. macOS, it uses brew, anything from brew. And on Windows, it uses Chocolatey, which does not have the same types of packages necessarily that you'll find in brew and apt, but it's another option for doing stuff. And then for maximum customization, you can just add arbitrary steps to the process, which can be anything that goes in an Azure step, and I'll talk about what that is later. So you can have pre and post test steps that just do whatever you want. So the way this works is that if you remember, the first template was the build template, and basically it just picks the right thing. It'll build a tarball using one of these options, and it checks for diesel, manila, and then falls back to looking for makefile.pl and build.pl. That was brew for Windows. Did I have a typo? No, it says Choco. Anyway, maybe you were, what was brew? Yeah, sorry, it's called Chocolatey. It's a package manager for Windows. Go to chocolatey.org. Or if you're asking what the Perl brew thing is, it's called Berry Brew, as Andy pointed out. All right, so that's the build stage. And then the build stage always uses a modern Perl. This is important for Dozilla, which will not build, which does not run, requires Perl 5.14. But your distro might be fine with 5.8. So the build stage always uses a modern Perl. It's just going to use the latest stable Perl release. It installs your build time dependencies. It also caches them between runs. And then it publishes a tarball as a pipeline artifact. I'll get into more of the details of what pipeline artifacts are later. One thing to note about the Azure caches is they're just deleted after a certain time period. So if you only run these tests once a month, it won't help you. But if you're doing repeated test runs, it's a huge improvement in the speed. And then the test stage, or rather test stages, all the test jobs run in parallel. In Linux, we're running in Docker because I have Docker images that have the Perls pre-installed, which really speeds things up. And macOS, it's just a VM, or sorry, macOS and Windows, you just get a VM. Each of the test jobs also caches all the dependencies. Which
oh my God, what the fuck?
Could somebody mute whoever that was? The joys of doing things on Zoom. So it installs all the relevant deps. It figures out what to install. For example, there's a test XT flag, which enables like author and release tests, and it will install those deps if that flag is needed. It uploads the coverage results if that's applicable for the particular job. And then it publishes the test results to Azure Pipelines. That publishing is kind of crap right now. It uses JUnit, but the module I'm using produces JUnit that doesn't, that Azure is unable to display nicely because the specific formatting of the JUnit. JUnit is completely undocumented, basically. It's very annoying. I have some improvements to this that are pending, but I haven't done it yet. And Ben Kaufman asked, would it be faster to use Windows Docker images? Maybe, probably. I don't know if it's even supported on Azure. When I started this, it wasn't, but that's something I might look into in the future. So another thing about the execution flow that I think is pretty cool is when the tools code runs, the tools code is almost entirely Perl. Like Travis Perl, and I think the thing Olaf and Nico worked on, they're like, oh, it has a bunch of shell. I don't know why people write all this stuff in shell. The Travis Perl shell is intense. It's very intense. I don't understand most of it. I'm not a shell expert, but you know what language I know pretty darn well? It's Perl. So almost all of the tools code is written in Perl. There is a bit of shell, especially in the templates themselves. That's how you execute things in Azure. In the VM or Docker image, you have to have a shell command, but it's calling Perl. But my tools code has its own Perl. So all the dependencies that it needs, you don't see them. So there's isolation between what's needed for the runners and what your project has. So if your project doesn't declare its steps properly, it's much more likely to be caught. Now, the one exception is I installed devel cover and the devel cover output modules in the testing Perls because that's what you needed to do coverage testing. One thing I could do is try to have separate images or installs for runs that use coverage or not. But anyway, there's a lot more isolation. So all these things, Olaf was like, oh, there's this problem with this and there's a problem with this. This project handles it. The only thing it doesn't handle that he mentioned that's the same problem is you're always getting recent updates. It runs the prereq install stuff every single time. And by the way, it uses CPM, so it does it in parallel. It's really fast. So here's what a test run looks like. So you can see we have our build distro stage, and I'll get into what these are, what stages are later. Builds a tarball, and then we have these three things, these three stages: Linux, macOS, and Windows. They all ran in parallel. Linux ran 31 jobs, which is a lot of jobs, a whole bunch of tests. macOS ran 3 jobs because we ran with and without threads. On Windows, there's no unthreaded Perls. So it just runs one test. And if we look, say, at one of these, you can see the individual steps. So it did a whole bunch of stuff. The probably most interesting one, well, in many cases is run tests. You can see just the full test output here. And there's lots of other stuff. So that's what it looks like. And you can see the whole thing took 11 minutes and 20 seconds of wall clock time, which is pretty darn good. All right. So speaking of speed, last time I ran daytime.pm tests in Travis, it was only on Linux. The whole thing took 33 minutes of wall clock time. This run you just saw was on Linux, macOS, Windows, more Perls on Linux because I think last time I used Travis, there was only 528, only took 11 minutes. And the other thing to not forget about speed is that there's also queue time. So with Travis, you only get 3 or 4 parallel jobs. So multiple, like if you push multiple times or have multiple branches queued or multiple projects you're working on, they tend to block each other for much longer than with Azure, where you get 10 jobs in parallel. So that's a really big deal. So yeah, why is it faster? I already spoiled the last bullet point, but the others are, I think, notable. Travis doesn't support Docker, so everything has to be installed from scratch for each job, even like the Perl itself. With Azure using Docker, you get a lot of stuff pre-installed, including, well, mostly Perl. Now, Travis Perl did pre-build Perl, so it would download binaries in many cases, which was pretty cool. But if you're using Travis Perl, one thing it does, which isn't so cool, is it builds the distro tarball for every single job and then unpacks it and tests it. Whereas with my system, it builds the distro tarball once, uploads it to the pipeline artifacts system, and then all the test jobs are just downloading that, unpacking it, and testing it. And then, as I mentioned, there's a difference in concurrency. I want to say, this isn't a dig against Travis Perl. It was awesome when it was created. It was a huge step forward for Perl testing. It's, it goes back, I don't know, 10 years already. And when it was created, it was state of the art, as was Travis. It's just things have moved on. Like the CI world has moved on in terms of capabilities. Andy is asking, what does Azure do that Travis doesn't, especially if you're using Travis already? Well, the big thing for me that would make me want to switch is it's much, much faster. I found the time it took to finish Travis runs really annoying. That said, is there anything you absolutely cannot do in Travis? Well, Docker, but even because Travis runs everything in VMs, you probably can run Docker on those VMs. So I don't know that there's anything you absolutely can only do in Azure. that you can't do in Travis. It's just Azure has a lot more features pre-made for you, and the speed and the great support for Windows, macOS, Linux. But I think Travis now supports all those OSs as well. So anyway, no, there's nothing apps. Then Jay, is Azure better than Circle CI? I actually prefer Circle CI. Circle CI is the best, but it has terrible limits for free software projects that make it unusable. When I was working on this, I started in Circle CI. First of all, its parallelism is much lower. It's like 4 jobs. But more importantly, while you get a certain amount of credits per month, the limits on Windows meant you had like an hour of Windows time per month, which was obviously unusable. I couldn't even like really develop this because I just would use all my time really quickly. So I gave up on Circle CI. I don't know if that's changed since then, but Circle CI is so good, especially it's the only one that has this awesome feature where in all the OSs, you can run a job and enable SSH and SSH into the machine and inspect why it's not working, which is just the coolest thing ever. I love it. All right. Any other questions so far? So that was about my project. And then next, I'm just going to talk about Azure in general. Anything? All right. So let's talk about Azure. The slides are on a site, and I linked them from the presentation. So if you want to go to the Azure Pipelines docs home, there's a link. Uses YAML-based config like everything. I say that with annoyance because I don't love YAML. I'll be honest, it's not my favorite. It's so complicated. Anyway, supports Linux on VMs or using Docker, macOS, and Windows VMs. Totally free for public projects, no usage limits whatsoever. And I should mention, so Mark was saying with Circle CI yesterday, well, you get this much credit and you can run 4 weeks worth of Linux. Well, okay, that's true, but if you're running like 20 different Perl versions for every push, that's not really 4 weeks of that. It's 4 weeks of one job. So if you run 20 jobs, it's a lot less. If you need to run a private CI server not in the cloud, what would you recommend? Azure, GitHub, Circle, they all support that. So again, I still think Circle is the best. And if you're doing it for private stuff, if you're paying, use Circle. That's great. General question. It seems like people tend to avoid threaded pearls. Why? Threaded pearls are slower than unthreaded pearls. And if you're not using threads, you're paying like a 10% speed hit or something like that. Don't quote me on the number. All right. So should you use Azure? Well, we've talked about a whole bunch of things, but one thing I haven't mentioned is I'm not sure what the future is of Azure Pipelines with GitHub CI, GitHub Actions. I've heard rumors that Microsoft is going to focus on GitHub and GitHub Actions in the future. One nice thing is GitHub Actions and Azure are using the same VMs under the hood. And they're really similar conceptually in the way they work. They both use YAML. The actual details of the YAML keys are different, but even there, they are broadly similar. So it's possible I will just port this project to GitHub in the future. The only reason, GitHub was my kind of second choice after Circle, but it didn't support things like caching when I was looking at it about a year and a half ago. So Azure was the best option then. GitHub, I think Olaf said, supports 20 parallel jobs, which is even more awesome. So it's possible I'll switch, and I don't think it'll be that hard to port. And it's also possible I just support both. I mean, it wouldn't be that hard. Like I said, these tools are written in Perl, and the tools are not too tied to Azure. It's the templates that are really closely tied to Azure. So you could build a separate set of templates for GitHub. They call templates actions. Those templates could use the same Perl code with a few tweaks, I think. So anyway, that's something to think about. That said, this works really well. Jenkins, no, Jenkins is the worst. Never use Jenkins. It's so buggy. I hate it. GitLab CI, I haven't looked at it too much. I think it only supported Linux when I looked at it, but it might be good. All right, so let's talk about kind of how Azure works, what it's made up of. So the top level is you have stages. So if you remember when I showed the daytime example, which I apparently closed, let's see if I can open it up. So you can see these are the stages, these big boxes. So a stage contains one or more jobs. By default, the stages run in sequence, just the sequence in which they're declared in your YAML, but you can run stages in parallel by declaring dependencies between stages. And if you have a dependency graph, Azure just figures out how it should be run. A stage contains one or more jobs. By default, all the jobs are parallel, and the jobs contain one or more steps. And each job can run in a VM or a Docker image. And in this system, these are the jobs, these three things, for example. And these were not run in parallel because you can also have dependencies between jobs. So this generate macOS test matrix, that is what everything else depends on. And I will explain the matrix in a bit. So jobs always have one or more steps. The steps are always run in sequence. There's no such thing as a dependency graph for the steps. So there's this notion of conditions, and that's how you get your dependency graph. So stages, jobs, and steps can all have conditions. Or sorry, this isn't how you get your dependency graph. That's something else. You could have like a condition like run this job if this other job was successful, or run this job if this job failed. You can also have conditions based on all sorts of other things. And in particular with templates, templates take parameters and you can use those in your conditions. You can also have dependencies. That's how you get your dependency graph. So stages can depend on other stages. Jobs can depend on other jobs. And again, Azure just like runs things in the right order as parallel as possible based on this stuff. And you can communicate between stages. I use communication loosely. It's not like a live message passing thing, but rather for stages, you can publish what are called pipeline artifacts. So I mentioned earlier that the way my system works for Perl is you have this build stage that builds a tarball, it uploads it as a pipeline artifact, and then all future stages can easily access that artifact. The artifacts can either be a single file or a folder, and that's it. It's just like a temporary file store for the duration of the pipeline. This is different than, I think actually these are available after the fact. So I was about to say something wrong. Anyway, yeah, published artifacts are available forever. You could also use them to publish like builds in Azure. But of course, if you wanted to say publish a build on GitHub, there's going to be a way to do that as well. You can also communicate between jobs and between steps. And again, this is not message passing. This is just a way to pick up output from an earlier job or earlier step. So you can use pipeline artifacts between jobs. You can also do pipeline variables, which are set in one step and read in another. And then you can do what's called output pipeline variables, which you can pass between jobs. So one job step sets it, and then a later job, which depends on the earlier job, can read it, which is pretty cool. And you can do some really great stuff with that. You can also do matrices, job matrix, job matrices. So this is a simple version where you say, okay, the strategy is matrix, and it's based on images. It's not as flexible as the GitHub matrix. You can't have like multiple matrix aspects like OS plus Perl version and so on, but there's a way around that that is, I think, pretty slick. And then you reference your matrix variable. You can see that here. I forgot to highlight this. And then the steps are just going to be the same for every job in the matrix. And it just figures out how many jobs to run. But there's a really cool thing you can do. So you can generate the matrix from a steps output. So here we have some bash code. It's executing print matrix. This is like a thing. This is how my stuff works. And then you do this special thing where you print out this thing to standard out with this special prefix, and then a bunch of gibberish in here. And you say it's an output variable, and then you print out the contents of $matrix, and it becomes available for future steps. So the contents of $matrix is JSON. Each top level key in this JSON is a job to be run. And then the objects in that key are the jobs variables. And this is like this crazy cool thing that you can do. So for my ci-perl-helpers, it figures out what goes in each of these stages in this first step, or second step in some cases, where it generates the test matrix. And that test matrix is what generates all of these jobs. So basically you get a whole bunch of parameters for each job, and it just does the right thing. I thought that was pretty darn cool. So the steps themselves are what you'd expect. You can check out code, whether it's this repo or another repo that you have a service connection to. You can have predefined tasks. There's lots of those. They're just like the GitHub actions that other people can write. And then you can have shell. So you can do bash on Linux and macOS, or PowerShell core on Linux and Windows. And then on Windows, you can use bash, command shell, or PowerShell. I suggest just using bash so you can use the same thing on all of them. I still had to do a lot of work with my Perl-helpers project to get everything to work on Windows. In particular, path handling can get a little weird. Sometimes you end up with paths with forward slashes, sometimes with backslashes. It's kind of a mess. I think in the future, I wouldn't be surprised if they support, say, Windows subsystem for Linux, but actually that wouldn't really be testing on Windows. So I don't know why I'm bringing that up. Anyway, you can also, one thing to note is the pipelines repo, the pipeline is attached to a project. The repo for that project, it's just automatically checked out by default. But you can change that, how it's checked out, or you can not check it out, or you can configure lots of aspects of that. There's all sorts of tasks that you can find, pre-made ones from Azure as well as third parties, lots of helpers for things like Ant, Maven, generic utilities like extract and archive, lots of other things, packaging, deployment stuff. There's a whole marketplace, and you can also write your own, and they're written in JavaScript. I think the GitHubs are also written in JavaScript. So I think, again, there's some similarities there. You can also have templates. Again, this is how my project works. So a template can come from the current project's repo, or you can reference another repo. You can define stages, job steps as templates, as well as variables. I didn't really go into a lot of detail on variables. It's a pretty straightforward thing. You set variables and they're available in your steps. Templates can take parameters, and so it's a way to configure things. Again, that's how my project works. Each of the build and the Linux, macOS, and Windows stage templates takes parameters, and those parameters can be used to influence how it works. There's a whole bunch more stuff it does. There's this thing called deployment jobs, which track deployment history. You can use different deployment strategies. You can set secret variables, so things like tokens for other services, your Docker Hub credentials, all sorts of stuff like that. You can have triggers for the pipeline runs. So you can do it on, you can specify different triggers for different branches and tags. Oh, branches, apparently that's Golem's slide. You can also have scheduled jobs, so you can actually make a cron job, which is pretty cool. You can run local agents, so somebody was asking about that. You can also do this strategy for test job splitting called parallel jobs, where you just declare that this should be run in 6 parallel things, and then Azure automatically schedules six jobs, and each of those jobs has some variables set to tell you the total number of jobs and which job in the sequence, in the set you are. And you can use that to partition your tests, for example. You could use it for anything, really. And there's a lot of other features, but I'm out of space. So for more info, I wrote a blog post about this ci-perl-helpers project, but it's not just about the project, it's also about my research on CI systems. So there's a lot of stuff. I think I talked about GitHub Actions, Circle, Azure, and maybe some others, can't remember. The GitHub stuff is probably fairly outdated. It's come a long way since then. I think the Azure stuff and Circle stuff is still fairly relevant. And that's all I got. So we have a whole bunch of time for questions. I thought this might take longer. I see people talking about Jenkins and Billbot and all that. Yeah, this would be great suggestions to take to Slack, or conversations to take to Slack. Dave Jacoby asks, the red in my CPAN testers is mostly BSDs. Is there a CI that tests against them? Can you run, you can't run BSD in Docker, can you? Does anybody know? Because if you could do that. there might be a way to run like can you run a BSD VM
Docker and
inside a
BSD?
Linux VM or something? If you could do that, that might work.
Free BSD VMs exist. I don't know if you can get one in Azure. I think.
Yeah,
You can.
yeah. I know there's free BSD VMs, but for like Azure, it would have to be supported by Azure, like as a target, and it's not. I mean, I'm sure there's probably a service out there that does this, but I'm just wondering if you could use Azure's Linux support to test BSD. It's good. It's a great question. I'd love to know the answer. Not sure you can run your own Circle CI, GitHub CI, or Azure CI. So Circle and Azure both support on-premise stuff. I think with Circle, you can run the entire thing on-prem. Like, I assume they give you probably a VM image or Docker or something that is the Circle software. You can run that locally. That's my understanding. Somebody correct me if I'm wrong. With Azure, you can run locally hosted agents, but I think the kind of the controller node is still the Azure cloud stuff. So I don't know that you can run Azure entirely locally. And with GitHub, I have no idea. But like I said, if you need that sort of thing, I really like Circle. I highly recommend it. I recommend it over Azure, except for testing free software stuff. So yeah, definitely take a look at that.